Okay, so we have a rocket that's going up. So first we're going to draw a free body. So we have gravity from planet Earth pulling it down, and some sort of rocket force. They're calling it thrust, so we'll call it thrust. Taking it up. And I'm drawing that thrust higher than the gravity because it's accelerating upwards. So that upward force has to be winning because the sum of the forces equals mass times acceleration with these little hats on the F and the A. That means the net force has to be in the same direction as the acceleration. So if the acceleration is up, that means our net force is up, which means up has to win. So I'm going to do up minus down because that's our net force equals ma. So F thrust minus Fg equals ma. Thrust is what we're solving for. The formula for Fg is mg. Some people just put mg instead of Fg. You can do whatever. College Board doesn't care. The mass of the rocket's 5. This problem says to use 10 for gravity. I normally use 9.8, but if they tell me to use 10, I'll use 10. Mass is still 5, and it accelerates at a rate of 7 times 7. Okay, so the thrust minus 50 equals 35. So that's 35 plus 50, so I say 85 newtons. I'm going to look at these units a little carefully though. Kilogram meters per second. Kilogram meters per second squared. For an acceleration. The acceleration should just be meters per second squared. What is this kilogram doing there? I don't know what that's about. 10 Newton kilogram. These units seem strange, but if they meant meters per second squared and meters per second squared, then this is the right answer.